Hello, ladies and gentlemen. Okay, this week we're going to talk about problem formulation and problem solving. The first two phases in the design process. Remember, there's 10 steps in the design process, 3 phases. Problem formulation, phase number 1. And that involves identifying needs, developing requirements, um, research, search and research. And, okay, so design, specifications to make an artifact. You start with a problem. So here's an example, say a house. Uh, One suggestion I made for a project is to make a Navajo hookah. And the idea of that would be to construct a model similar to what you're seeing here. That you would show the layout, the exact dimensions. The idea is you'd make something that looks traditional, like it was built centuries ago, but is built to modern standards and modern construction um, rules, building codes. So anyway, you're designing something. The 4 steps in this phase: identifying the needs, defining the problem, search, which includes go to the library, find out what others have done, similar products, things like that. We don't want you reinventing the wheel. And then identifying requirements. A Parkinson's keyboard, for example, somebody built one from scratch. And it really wasn't very good. And I looked at my Wacom pad here. It's a pen input pad that takes touch inputs. And what Parkinson's people need basically are guides, regions. So they have a small keyboard, shall we say, a big keyboard. Well, this is a great thing to start with, that big keyboard, because you could design a 3D printed grid that goes over this tablet, and then the person would press whatever keys they had to, a grid of 9 or 12 keys or something like that. You'd actually be touching the tablet. So you can start with stuff that's already been built and then modify it. That is a solution. And sometimes it's a good solution. That's where your searching comes in. Are there any close ideas? Don't reinvent the wheel. Things like that. Okay. That reminds me of a little story, by the way, in the searching phase. Another story that there was a food manufacturer, and they put their stuff inside of a box, and some boxes were empty. And so they invented a very expensive, elaborate machine to detect if a box was empty and make an alert, give an alarm so that a worker could take care of it. And the next month, they didn't have any empty boxes. The machine did not detect any empty boxes, and there were no empty boxes. It was doing its job right, but there weren't any empty boxes. So the boss went down to investigate on the factory floor. He said, oh yeah, one of the workers got fed up with the alarms going off all the time, that he set up a fan to blow the empty boxes off the conveyor belt. A $10 fan versus a $100,000 machine. So that's why you do that. This is why that story illustrates why we need to take some time on this step, defining the problem very clearly, and understand our cost-effective solutions to the problem. So take some time on this. Okay, so here's the first phase: identifying the needs, defining the problem, searching, and defining requirements. Okay, Second phase, solving. Third phase, implementation. You may have to go back, iterate. You have to manage the project. There's that red line. So this gets the idea of the feedback loop, that it's not one time through and done. It's not a linear process. You get to here, you might have to go back and so forth, back and forth a bit. You also need to plan, and you need to plan some prototyping steps, that you get to a certain point and you test a prototype. You test something less than what your full project is. You test the different pieces to make sure all the pieces work before you integrate them all together. And of course, the space program of the 1960s did exactly that. They didn't design a moon rocket and go to the moon. They designed 3 separate programs, Mercury, Gemini, and Apollo. And then they designed, they had to learn to rendezvous in space. So that was the Gemini. They had to learn to do spacewalks. So they got experience doing that. So they got experience with all the steps. Do the same with your project. Don't presume something will work. Do a test to figure out, and that's in the problem-solving stage mostly. But also in your planning, when you're thinking about your timeline, built-in time to test prototypes, to test the pieces that go together to make your project. Formulation, that's where we're on. Okay. Einstein. Oh, come on. Where's that Einstein quote? There it is. It comes up. Formulation of a problem is far more essential than its solution, which may be merely a matter of mathematical or experimental skill. This is a very important step, in other words, in designing a product. Okay. Focus on the problem, not solutions at this point. What problem are you trying to solve? Something that needs improvement. And I can think of, I mean, it's just, I go through every day and I think I run into things that, oh yeah, let's do this. And usually I'll take, okay, let's put a tennis ball on the end of the string in my garage so I know where to park my car. I mean, right? You could try to sell something like that, but it's so simple, you don't need to. Okay. Accept it. Accept that there is a need and that it needs to be filled. We need to solve it. And companies will sometimes say, no, we're not going to tackle this problem. Yes, we'll tackle this problem. They decide whether they're going to do something or not based on what they think the market is, all that sort of thing. They try to make judgments that way. Sometimes they make wrong judgments. I worked for Vina Technologies and they died. The company went belly up. And the main reason it did is that they were trying to make a BlackBerry replacement. A BlackBerry also ran. And BlackBerries were selling for about $200, and they developed a product that cost about $500, but it was smaller, I said, people aren't going to buy it. I did an economic analysis. Nope, they weren't going to buy it. It's it's better to stop the project now because it's not going to have a market. Sure enough, it didn't have a market. Some VP was pushing it. He didn't want to believe it wouldn't sell, and he ran the company into the ground because of it. Okay. Dissatisfied with the situation, confront it. Recognize a need exists, accept responsibility, and adapt. Change. Engineers were being innovative. We're trying to figure out new solutions. It's risky. Okay. I'm going to end my video here. Going to pick up the next video on the next slide.